Welcome to the TSASK B149.3 and SAS Codes of Practice presentation for the 2025 code cycle. I'm Doug McKinnon and I'll be your presenter. This presentation will cover the substantial changes to the CSA B149.3 25 code for the field approval of fuel burning appliances and equipment and the 2025 Saskatchewan Codes of Practice for the CSA B149.3. We will be looking at new definitions, wording, and technical changes in the 2025 code. In the Saskatchewan Codes of Practice, we will be reviewing the technical changes and the new format. Once again, like the presentation for the B149.1 and the .2 presentation, the slides for national code changes will have a white background. The Saskatchewan Codes of Practice will have a blue background for their slides. The Saskatchewan Codes of Practice for the .3 has also been reorganized into two sections. Interpretations, which are enforceable. The second section is informative, which is good reference material that contractors find useful. So let's start in Section 1, Scope. 1.6 Gas Type. The term gas has been expanded to allow new directions in natural gas blend and hydrogen in the Canadian gas industry. These requirements were developed by a working group to assist with the field evaluation of gas-fired equipment that will utilize hydrogen-natural gas blends. These requirements are intended to standardize the approach for the construction and approval of equipment utilizing hydrogen blends, including the provisions for a risk assessment, hazard-based safety engineering approach to such projects. Section 3, Definitions. Fume incinerator is defined in the 2025 code, and most of these definitions come from or are supported by the NFPA 86. Installer would mean a licensed gas contractor in the province of Saskatchewan. The definition of oven and the sub-definitions come from NFPA 86. Batch process oven. An oven or furnace into which the work charge is introduced all at once. Class A oven. An oven or furnace that has heat utilization equipment wherein there is a potential explosion or fire hazard that could be occasioned by the presence of flammable, volatile, or combustible materials processed or heated in the furnace. Continuous process oven, an appliance into which the work charge is more or less continuously introduced. Low oxygen oven, an appliance that utilizes low oxygen atmosphere to evaporate solvent to facilitate solvent recovery. Operator is now defined in the .3 as an individual having knowledge, experience, and training for startup, operation, shutdown, and/or emergency handling of appliance. This could be a maintenance person or a process engineer that is responsible for the equipment. Owner is any individual, firm, corporation, or company that is responsible for the safe startup, operation, shutdown, and emergency shutdown of the appliance. This definition is very similar to operator, but also shows how the owner is responsible for the operation of equipment. A small wording change from the 2020 to 2025, changing prove to proven, in this definition as the pilot flame is proven throughout the pilot burner operation, not just prior to the main burner gas being admitted. Process appliance has a definition in the 2025.3 code. An oven or furnace where combustible gases in addition to the fuel gas are present within the appliance, either by the introduction of the gas or as a result of the work being performed within the appliance. There was a wording change in protected inlet pressure from 2020 to the 2025 edition. The intent is the same, but the wording just tightens up to include all valve train components if there is a failure of the nearest upstream pressure control device. Safety control or safety limit control components have been defined. It's simply any component of the appliance that forms part of the burner management system, which results in a shutdown that requires a manual reset or verification from the operator. Safety ventilation is the ventilation necessary in a Class A oven to keep it below the maximum permitted lower flammable limit, or LFL. The manual shutoff valve definition was approved by the B149.1 committee. Another new definition is spring return valve, a normally closed, manually operated valve that is opened manually and closes via spring return after the valve operator is released. Valve train definition has been reworded in the 2025 code to read an assembly of all fuel confining devices, controls, piping, tubing, fittings, and hoses of an appliance downstream of the manual shutoff valve for each fuel to the inlet of the burner or burners. Moving on to Section 4, Pressure Regulators. The changes in 4.6 gives you more options for pressure greater than 0.5 psig. So as before, you can use a lockup style pressure regulator, and now you can use a pressure regulator that is integral to a multifunctional control. For the Saskatchewan Codes of Practice 461, under Interpretations, gas to a combustor, the options are for 5 psig and over, a regulator per clause 4.1. For pressure below 5 psig, a regulator per clause 4.1. Or your other option is an inline flame arrestor and overpressure protected by a relief valve. 4.9. Certification requirements. A pressure regulator shall be a certified pressure regulator, or B, if a non-certified pressure regulator is installed, that regulator, when installed on the appliance, should be monitored by both high and low gas pressure switches. Section 6. Manual shutoff valves, manual isolation valves, and test firing valves. 6.1. Manual isolation valves. This clause was rewritten to bring some clarification from the 2020 code. This is for when you have an instance with 2 or more fuels and the pilot comes off the main valve train. The manual valves need to be upstream of the main gas safety shutoff valves and downstream of the pilot line connections. If we look at the note, it gives the rationale that the pilot can be running with the main valve train being isolated. 6.2. Requirements for manual and test firing valves. The changes are in B, with the additional wording having a clear indication of the open position of the valve. Then the clause continues as it always has, with a handle of the valve in parallel to the gas flow. In Part E, valves larger than nominal pipe size 4-inch may have a gear-operated hand wheel. Section 7. Pilot safety shutoff valves and burners. 7.1.4 was changed. The sentence in red has been removed as it is redundant because valves are required, so the additional statement that they cannot be bypassed is unnecessary. 7.2.5. Trial for ignition period. This clause takes out intermittent and interrupted pilot flame and just uses the term pilot flame in the 2025 edition. The requirement for 10 seconds has stayed the same. Section 8. Main safety shutoff valves, input flow control systems, and main burners. First up is 8112. This is the clause from 2020. In 2025, this clause was rewritten to be more concise. For 12.5 million BTUs or greater, the main safety shutoff valve shall be A, supervised by an approved VPS, or B, equipped with an automatic vent valve that complies with 8114. Saskatchewan Codes of Practice 8141, gas to a combustor. A waste gas stream to a combustor up to and including 400,000 BTUs per hour shall have two CSA 6.5 safety shutoff valves, or one certified to 6.5 CI. Saskatchewan Codes of Practice 8151, over 400,000 BTUs per hour up to and including 5 million BTUs per hour with a CSA 6.5 CI safety shutoff valve, no proof of closure is required. Saskatchewan Codes of Practice 8161, over 5 million BTUs per hour shall have two 6.5 CI safety shutoff valves, but proof of closure is still not required. 8113. For a complex or integrated facility, this allows you to replace the requirements in 8112 with a maintenance program as per IEC 61511-1, Clause 16. Also see the note where the facility operator may use the applicable manufacturer's recommendations, industry standards or codes, good engineering practices, or prior operating experience to develop appropriate maintenance procedures and maintenance schedules. Here is an example of an IEC 61511 safety life cycle. For anyone wondering, IEC stands for the International Electrotechnical Commission. 8114. There has been deletions from this clause and has been rewritten to be more concise. Automatic vent valves without VPS or valve proving systems shall be A, certified to CSA 6.5, B, closed during normal operation, C, open when the burner is not operating, D, normally open, E, shall be installed on a vent line downstream of the first safety shutoff valve, and F, have an outlet terminate to a safe location. New Clause 8115, Automatic Vent Valve Requirements with VPS or Valve Proving System. A, be certified to CSA 6.5. B, closed during normal operation. C, can be either normally open or closed. D, shall be installed on vent line downstream of the first safety shutoff valve. And E, terminate to a safe location. Table 8.1. This chart gives you the size of the vent valve and vent line size based on the safety shutoff valve upstream of the vent valve. This chart has been misinterpreted as minimum size, but it does not say anywhere on the chart that this is minimum. The most important part is not the actual size of the takeoff connection, but the vent valve and vent line sizes. 8117. Automatic vent valve sizing. This clause has been revamped. Here are your options. A, the vent valve and vent line sized as per table 8.1, which we just went over. Or B, when using a VPS system, vent valves are minimum nominal pipe size 1/4 inch and minimum vent line nominal pipe size 1/2 inch for piping or tubing. Refer to Table 8.2 for sizing the vent line large enough to vent the leak detection limit of the VPS. Table 8.2, leak detection limit of a VPS in cubic feet per hour using natural gas. We are showing you a condensed version of the table on this slide. 8.1.18 VPS leak detection limit and action upon detection of leak. A valve proving system, or VPS, shall have a leak detection limit as per Annex E. If a leak is detected, the VPS test sequence shall fail. E5 gives the recommended leak detection limits. 8.1.19 Integration into the VPS test sequence. The VPS shall be integrated into the startup or shutdown sequence. 8.1.20 is the same requirements in 2025 as 8.1.17 in the 2020, which requires the VPS to prevent burner ignition if the test sequence fails during startup. 8.1.21 Requirements for VPS test sequence on shutdown. The requirements are broken down into a couple of sections. For a gas engine, if the VPS sequence fails on shutdown, the VPS shall alarm the engine control system. For an appliance that is not an engine, if the VPS system fails on shutdown, a VPS test sequence will be required on the next startup, as per 8.1.20. If the VPS test sequence does not fail on shutdown, a sequence test shall not be required for 8 days. The 8 days is based on NFPA 85. 8.1.22 VPS alarm only conditions. In this situation, since both VPS and normally open vent valves are used in combination, allowing the VPS to alarm should be permitted since the vent valve prevents gas from entering the downstream combustion chamber. By alarming only, it allows the system to be operated but also notifies the owner that valve maintenance needs to be scheduled. 8.1.23 Low, high firing of a single burner. This clause gives you the requirements for having a third safety shutoff valve in parallel with the second and downstream of the first. The two valves piped in parallel shall be de-energized from the same combustion safety controller and is not considered a bypass as per 8.1.1e. Saskatchewan Codes of Practice 8.1.24 Safety shutoff valves for combustors. This gives an exemption. Safety shutoff valves with proof of closure, temperature control valves, automatic vent valves, valve proving systems, or VPS are not required on the waste gas stream to a combustor. 8.3.7 from the 2020 code has been rewritten and clarified, but the intent has stayed the same. Clause 8.3.7, wording has changed to, fuel shall be prevented from entering the burner until sufficient airflow to the burner is proven. Then it gives clause 12.6 and 16.2.5 to reinforce the requirement. Failure of airflow shall require a loss of fuel to the burner. 8.3.11.1 Trial for ignition of a proven interrupted pilot. The basis for this approval is the pilot burner is physically located so close to the main burner nozzle that it would be impossible for the proven pilot not to ignite the main burner gas. Therefore, if the pilot burner is proven, then the main burner must be ignited as well, even though there is no independent flame sensing installed. Using this same basis of approval, the capacity of the burner and the type of control system is not relevant as long as the pilot burner has been field tested. 8.3.11.2 CSA decided the existing definition of proved pilot should be modified to proven pilot because the existing definition only included proving the pilot before gas goes into the main burner. But it should be proving the pilot throughout the pilot burner operation. This resulted in updating a few clauses using the new term proven. 8.3.11.3 gives the requirement if the pilot does not meet the requirements of 8.3.11.2. 8311.4, trial for ignition with direct spark ignition, shall meet the requirements of 11.2.3, direct spark ignition of main burner. Well, let's take a breath as we move into Section 9, additional requirements for liquid propane valve trains. 9.2 in the 2025 code has some additions in the wording. Certified has been added, and the requirement of temperature and pressure. This allows contractors to use certified materials and components and not require approval from the authority having jurisdiction. Section 10, Applications. 10.1.2.2, the following clause has expanded upon the documentation requirements of existing clause 10.1. It is written as a list and using appliance complexity as a separation between complex and simple appliances, where more or less documentation should be required respectively. The additional requirements were added to give some criteria to appliance IOM documentation, which is radically inconsistent at the present time. (10.1.2.3). This clause gives the requirements for complex appliances. You may apply directly for field approvals on GEIS. This is the same place you submit your gas permits. Just select Field Approval. 10.1.3. Appliance flue gas testing. This gives a requirement that oxygen and carbon monoxide shall be included in any flue gas analysis. 10.3.3. Pressure test point connection. This gives the requirements for valves to comply with Clause 6, or a spring return, gate, or block valve, if approved. 10.10. Hoses for conducting propane and natural gas. There are two additional active standards, CSA 8.5 and UL 536, for the hoses which should be included in the code. As stated in B149.1, hoses certified to CSA 8.3 cannot be used for liquid propane. Section 12, Safety Controls. 12.1.6. Disabling, isolating, or bypassing safety controls. This is not allowed except under Clause 12.1.7 and 12.7.2.3.4. 12.1.7. Maintenance and testing purposes. This gives the requirements where manual shutoff valves may be installed and the conditions that must be addressed in A, B, and C. 12.3. Low fire start. The requirement for a proven low fire start has increased to an input in excess of 3.5 million BTUs per hour, unless otherwise approved. 12.5.3.1. Pilot gas low pressure safety control for continuous and intermittent pilots. This clause was rewritten to reduce some confusion and misinterpretation. There was a note that was removed and added into the code. A and B lay out the requirements for when a pilot gas low pressure safety device shall be installed. 12.5.3.2. Pilot gas low pressure safety controls for independent pilot gas. This is the requirements for if the pilot has a different fuel supply. This gives the requirements in A and B for when a shutdown is required. This clause, like the last clause, was rewritten to be more concise in the interpretation. Continuing with 12.5.3.2. A pilot does not require a pressure safety device if the pilot is protected by the main fuel low gas pressure safety device. For a main burner with more than one fuel type, Clause 6.1 requires a manual isolation valve. If the isolation valve isolates the pilot from the main fuel low gas pressure device, then it needs its own. Saskatchewan Codes of Practice 12533, gas to a combustor. This gives the requirements when a high and low pressure safety devices are required based on 5 psig and over and below 5 psig. 1254. Low gas pressure safety limit control time delay. The time delay on a low pressure safety limit required under clause 1252 B shall not exceed 10 seconds. This allows gas pressure to recover after burner startup situations. 1261 Air Proving Switch. 12611 General. This was rewritten to give more clear expectations for this requirement. This gives you three options: the next two clauses or an approved equivalent acceptable to the authority having jurisdiction. Make sure to reference the note at the bottom as well as Annex D. 12612 lays out three options. A. When the air control damper is located downstream of the air supply device, a single or differential air supply proving device shall be installed between the outlet and the damper. Or B. When an air control damper is located upstream of the air supply device, a differential air supply pressure proving device shall be installed to measure between the inlet and outlet of the air supply device. C. For any control damper location, a flow or differential proving device shall be installed on the air supply line across a fixed orifice or at the burner throat. This device needs to prove 80% or more of airflow during pre-purge, and 2. 80% airflow required at minimum firing rate during normal operation. 12313. This is when there is no control damper or a fully metered system. The airflow proving device shall be a flow or differential pressure measurement device or single point pressure measurement device installed downstream of the air supply device. B is the same requirements in 12612. Section 15, Initial Startup Procedure. 15, Initial Startup Procedure. This refers you to Annex A as a recommended startup for equipment over 400,000 BTUs per hour, but Annex A is not mandatory. Section 16, Additional Requirements for Process Appliances and Atmosphere Generators. 1654, Certification. A high-temperature limit controller shall be certified to one of these standards or approved by the authority having jurisdiction. 1610, Class A ovens. 1610-1, General. 1610 lays out the procedure for determining the minimum ventilation rate for a Class A oven or furnace, looking at many criteria. Also, the term ovens and furnaces are interchangeable when used in this code. Annexes. Annex A has been rewritten to give more details on how to perform a pilot turndown test. Annex E, Guideline for Valve Proving System, or VPS. E1, Definitions. More definitions. And yet more definitions. Annex E lays out proper use of VPS and testing requirements. Annex J, Mobile Outdoor Food Service Unit. Annex J is mandatory in Saskatchewan. Saskatchewan Codes of Practice. Annex J of CSA B149.3-25 is adopted in Saskatchewan as mandatory for inspection of mobile outdoor food service units. This is to align the requirements of mobile outdoor food service units in the province. Annex L, hazardous location in reference to electrical requirements with appliances or equipment. Annex M, recommended considerations for fired appliance installation, operation, and maintenance manuals. Annex N, developed to assist with hydrogen natural gas blends. Don't forget to check out our website at www.tsask.ca. You can also contact us by phone or email. This concludes our presentation on the 2025 CSA B149.3 code. If you have any questions, please reach out to your local gas inspector at TSASK.